Okay, so today we are going to graph piecewise functions. And what all that means is that we take two pieces of two different graphs and we're going to graph them on the same graph to make up one big function. So this graph, f of x, is made up of two different functions, the first one being negative 1/2 x, but only when x is greater than 4. So that's saying that we're going to only have that part of the graph from 4 and then every number bigger than that. And then our second graph is going to just be x when we have, which is linear, when we have all values less than 4. So we do want to still check and make sure that this passes the vertical line test. It's still going to be a function. Those two pieces of the graph won't cross each other, and we won't ever have two y values for the same x value. So when we go about doing one of these graphs, we kind of break them apart into the first part and the second part. So our first part is at negative 1/2 x. And we always look at our rules here. So this is saying if x is greater than 4. So whatever number you see in your rules, we're going to use that in our table to start. So I'm going to write negative 1/2 x over the first table here. And then my first x value, because my rule says 4, it's going to be 4. And so we want numbers that are bigger than 4. So 5, 6, and 7 are all bigger than 4. But when I look at my equation, I probably don't want to use 5, 5, and 7 because we want to divide by 2. So I'm actually going to change this and pick values like 6, 8, and 10 because I'm going to divide by 2. I want even numbers. So now I'm going to plug 4 into this equation. So I'm going to multiply by negative 1 and divide by 2. So I've got a negative 2, negative 3, negative 4, and negative 5 when I evaluate each one of these x values into that equation. Now my second equation here is just y equals x. So I'm going to write that over my second table. And I'm going to, again, pick values. I know that I'm starting with whatever is given to me. In this case, x is less than or equal to 4. So I'm going to start with 4. And then I want numbers that are smaller than 4. So 3 is smaller, 2 and 1 are all smaller than 4. And so I'm going to evaluate this function, 4, 3, 2, 1. We're just taking itself. And now comes the part where we're going to graph. So we look again back to our rules to know whether we're going to have an open circle or a closed circle. This inequality is greater than, so that means we are not going to include the 4. So I'm going to draw an open circle next to it and know that I have that linear line for the rest of the graph. The only open circle is at that first point. The rest will be closed. In our second piece here, we've got x is less than or equal to. Since it's equal to, we will include that point, and then the rest of our graph will extend as well. So those are just quick reminders by our table so we remember what our graph is going to look like. When I go ahead and plot these points, I will have an open circle at 4, negative 2. So at 4, negative 2, I have an open circle. And then at 6, negative 3, at 8, negative 4, and at 10, negative 5. So I'm just going to extend that way. So this is going to head towards all the values that are bigger than 4. We see that that's true. Those are x values bigger than 4. And then the second piece of our graph, we'll have a closed circle at 4, 4, and 3, 3, 2, 2, 1, 1. So 3, 3, 2, 2, 1, 1 will look like this. Now again, this graph, we'll notice, will pass the vertical line test. So if we have any x values, there's no repeats. Even here we have one closed and one open circle, so those aren't going to repeat at all. And the last thing we want to do again is look at domain and range. So if we look at domain and range here, we see that all x values are included from negative infinity to positive infinity. Even though this is open, this is closed. So we do include 4, so our negative infinity to positive infinity. And our range will then be, we have negative infinities covered until we get to this highest value of 4. Nothing is higher than 4 on this graph. And so 4 is going to be our max value there. So negative infinity to 4 on our range.